waste, they were able to deliver that project for $17.9 million. And so cost at completion, as you see in the little cut-in box, cost at completion was 5.2% below target and 18.6% below market. And this, even though it was a relatively small and simple project, this went a long way to persuade Sutter Health to incorporate target value delivery into its capital program. So Sutter Health adopted lean project delivery in 2005 because their projects were consistently going over budget and over time. They weren't getting what's worse, they weren't getting what they wanted by way of functionality, that is fitness for purpose. Shown here is their old project delivery process. Okay? So just walk through it very quickly. From business planning, they developed a business case, then they engaged their capital project delivery team, FPD, and then did some planning, setting context, scope, and budget, went to the board for approval, and then launched design, okay? And after design, they went back for final board approval and on the large projects, and then went for permits and then construction, okay? Now, what happened but as I said, they were consistently going over budget and over time. And so they thought about how to change it, and looking at target value delivery, they made the changes you can see here. So the project planning was put further up front, and a more detailed feasibility study, setting target, detail, scope, and budget, involving the owner, the architect, the construction manager, general contractor, and an estimating consultant. Then they went for board approval. And at that point, they had targets to which to steer design, okay? So, and that's the key change, is that if you depend upon design to determine what things are going to cost, you don't have any way to focus and correct through feedback the design process. Right? And so there's a natural tendency for things to get more expensive as you get more lines on drawings or more detailed models. Right? Now to talk a little bit about the way in which in target value delivery targets are thought about and value is thought about, I think this, I find this a useful diagram. This is from a study done for the National Health Service in the UK back in 1998. And what they were looking at was a hospital. And they wanted to provide a kind of a broad general guideline to the relationships of costs within such projects. So if we take construction cost as a 1, if you see it on the left-hand side, the little small circle with a 1 in it, let's say that's the unit of cost. If that's a unit of cost for construction, design would be about 10% of that, okay? We're not trying to be exact, we're trying to be representative. So over a 20-year period of the use of that hospital, the cost to operate and maintain it would be something like a 4.3. Right? So 4.3 times the cost of construction. In that same period, the cost to use that hospital to deliver healthcare would be a 42, another order of magnitude. Right? So all those bubbles, the design, construction, operations and maintenance, and business costs, all count as costs, and they have to be smaller in sum by area, because they're represented by their areas, than the big blue bubble on the right, which is if we might say, the benefits that they expect to get from use of that hospital. Not all of the benefits are listed here, right? Some of them are more easily monetized than others, but they all can have values placed upon them, right? So what I would say from this is that fundamentally, when we do projects, we should be looking at the whole life of that project, right? And that is quite often done if you're in the position of a Procter and Gamble, let's say, right, who builds manufacturing plants to produce products for sale, retail products, right? So, and over that life, then you can look at the relationship between benefits and costs, the value of each, right? And you obviously want your benefits to exceed the sum of the costs, or you're going to go out of business pretty quickly, right? So I would say that if you want to think about what's the fundamental target for a project, a capital project, it's net benefits in use over its life, right? So here's the process in very broad strokes for TBD. Develop the project business plan, validate it, set targets for what's wanted and conditions of satisfaction, including time and cost, steer design to targets, and of course, steer construction to targets, because you don't have value delivered to the client if they only have the design. They want the building or the bridge or the whatever it is. Okay, so in moving from an idea to a go, no-go decision, several key questions are asked and answered. What benefits are wanted from the project? What's the lowest acceptable ratio of benefits to costs? That determines the allowable cost. The 18.9 million in the case of the Sutter Fairfield example. How does this project compare to others as an investment alternative? That's a relevant question, except for projects that are mandatory for the continued existence of the client, maybe regulatory, legal requirements, right? Or even responses to competitive pressure. Given risks and uncertainties, can this project be completed successfully? Okay. So answering these questions involves producing and assessing a business case and producing and assessing a project execution plan against risks and opportunities. That's what we mean by validation. Assessing a project execution plan against risks and opportunities. Okay. So let's just walk our way through this one. Hold on a second. If I'm getting ahead of my notes. Right. Okay. So again, there's lots of detail underneath this, but I think it holds together conceptually. So the client has to answer the question, what do I want? What's it worth to me to have it? What am I willing to pay? And then what am I able to pay? Right? So at this point, you will have determined what's wanted and provisionally what's wanted and an allowable cost for it. So you see that scope and cost, that is what's wanted and the cost to get it, what price we have to pay and various ways of paying prices, right, are two sides of a single coin. So if you change the scope, if you change what's wanted, you must change your allowable cost, right, because they're a reflection one of the other. So then it gets interesting. I'll walk all the way through, then I'm going to come back to this point of how much will it cost, because that's the conceptual estimating piece, right? So if your expected cost, what it would cost based on the market, is less than the allowable, then you really don't have a problem in terms of money, right? You may have a problem in terms of time or something else. But if that's true, then you go on to the question, is it feasible? I'm sorry, if you go on to consider the possibility of adding benefits, value adds, because you have more money you're willing to spend, it's worth more to you than you're going to have to pay. Once that's done, then you may consider setting stretch goals. That is, you have to be very careful with stretch goals. We don't want to get greedy, because taking waste out of a process, out of a system, is something that really happens over time, right? And it's only so much can be done in a single project. So, but nonetheless, you want to be presenting some tension, some stretch in the pursuit of continuous improvement. And then you set your allowable cost and expected cost equal, and then you validate the business case. And I'll talk about validation more in just a second. Going back to the diamond where it says EC less than AC question mark, if we take the no arrow out of that, then we have an interesting problem, right? Because what we want appears to, it looks like it's going to cost more than what we're willing and able to pay. That is more than it's worth to us to get it, right? So, so the question of feasibility here is the question, is it feasible through innovation and hard work to reduce that gap? So we're doing a gap analysis between allowable and expected, yeah? And of course, this is a bit like a sniff test, right? If it's considered definitely not feasible, you either alter what's wanted, going back up to the top of the flow chart, or you stop the project. Probably too few projects are stopped at this point. If it's considered perhaps feasible, then there is some process of validation, right? So, okay, so let's go back to the question of what's the expected cost? How do we do that? There's two basic ways. One is to benchmark against similar projects. And that was what was done by Sutter Health in the Fairfield example that we showed earlier, right? And the other is, and this is part of the research I'm doing currently on conceptual estimating, is to develop a building information model from the voice of the customer, then cost the model. That does not design the project, but it provides one design of the project that delivers what's wanted in terms of functionality and within cost, right, and time. And so costing that model provides a useful guide for setting target cost for what you want. Okay, so this is what was done. This was actually done on another Sutter Health project. It's only recently been completed. I think it had a long history, but it's about a $1.5 billion hospital project in downtown San Francisco. And when they started, they identified 9 projects that were somewhat similar, and then made adjustments to those projects for the differences that they knew between them and the project that they were planning to build, right? And from that, they determined that there was a 14% gap between the allowable and expected cost, right? Now, let's see if do this. So just to tell you the conclusion of that, so what they did was they made a provisional commitment to the project, that is to do design up to the point where they could decide one way or the other whether that gap could be closed, right? And then they reserved the possibility of going back and revising what they wanted, and in order to fit the project within what they were willing to pay for it. But
Dr. Ballard, there was a question about how long it takes to prepare the expected cost to calculate it.
It depends on, well, in either way, it doesn't take very, very long. I'll show you some examples in a minute about the alternative of using the building information model. And that can be done within 1 or 2 weeks.
Okay, thanks.
Okay. Okay. So what they did was they started design, and using the target cost that was set, their allowable cost, they steered design to produce to fit within that cost. Okay.
Oh, sorry, Dr. Ballard. Mr. Ayman Khalifa, can you please mute your mic? Ayman Khalifa, thank you. Okay, sorry, Dr. Ballard, please proceed.
Okay. Okay, so it took, I think in 14 months, that project was the expected cost for that massive project was $7 million under target, okay? And at that point, the project was considered, it was fully funded, right? So that's an example of using benchmarking as a method for determining expected cost. Now let's look at the other alternative. So what Hatala, they call it a cost model, but it's actually a software for producing cost models, right? And it does that, as I said, by producing a building information model based on the voice of the customer. And that means that they can, for every specification that in terms of functionality and levels, for example, the lighting level within spaces dedicated to certain uses, right? Every time a choice is made, that choice changes the cost estimate, right? The expected cost. And it does that because it does it by embedding algorithms and formulas used by architects and engineers from, for example, I want to be able to hear a pin drop from any seat in the theater, the voice of the customer, it's not the voice of the engineer yet, to the cost of impacted components and systems. So if you change the requirement, the estimate changes accordingly. And right now we have 39 projects for this company, Hatala. They're a cost management and construction management firm based in Helsinki, Finland. Average cost of completion is about 1% under the conceptual estimate. I think it's actually 0.9. They have some range. All of those are more than occurred earlier in that list of 39 projects. They introduced their 5th computer program and are much more sophisticated now, only for the last 5 or so. So it's getting better. So, but the range from that whole 39 projects is minus 15% under to 11.8% over. The average under is 3.66%, the average over 3.32, with a standard deviation of 4.9. Okay. If you take the most recent 10, the standard deviation is 4.5. So it looks like there's something important there. So this is the kind of information, the algorithms and equations that are embedded in the software. So if you want to determine the number of lamps, luminaries needed to provide required lighting, there's the formula, right? So modeling, one of many possible design solutions, enables counting those luminaries or the size of the main switchboard or you name it, and then applying cost to quantities and types of products to be purchased. And the same is done for services, the cost of labor and equipment and so forth. Okay, so if we go back, so we've analyzed the gap between allowable and expected. Now we must decide if the gap can be closed, right? So there are 2 publications on validation. I think I've added them here. Here you go. So you'll have these slides after, but that one is, I can move this this just a little bit and then you can see it. Okay, this is from this new current process benchmark for the last planner system. It'll be published if I can stay awake long enough. Be published by the end of this month, and that talks about using stochastic planning methods in project master planning. And then this one on the bottom left is a special form of validation that's used in integrated project delivery projects or other projects where there's shared risk and reward of the key players. Uh-oh. Huh. Where's my, oh, I think we're a little bit early for that. Oh no, maybe not. Okay, some key points. So as I have said, the natural target for built environment projects is to provide the customer acceptable net benefits and use of the asset. Targets are set for what's wanted, benefits, and constraints on their delivery, such as cost, location, time, and so on. Setting cost targets is done through analysis of the gap between allowable and expected cost. Expected cost is typically estimated by benchmarking. That's my understanding, that's the most common form in use in the industry. An alternative way of determining expected cost is to build a model from the voice of the customer and cost that model. I think that will be the better way and it will become more popular. Go, no-go decisions are made by producing a project execution plan and assessing if the project can be completed with acceptable risk. Okay. So I thought in anticipation of questions, why is this not going forward? Oh, I just have to click it, there we go. So I thought I might just feed the lion a little bit, some questions you may have. Why not try to pay the least for what you want? Right? What's wrong with that? Well, what's wrong with it is it's self-defeating. Trying to pay the least tends to result in paying more than you would otherwise, mainly from perverse behaviors by service suppliers. Wouldn't it be better to first design than cost? Well, I've said this already, but a reminder, with no target cost to meet, designs tend to be produced that exceed what clients are prepared to pay, resulting in rework and often extended project durations. Is it always appropriate to design for the whole life of the asset to be constructed? I think yes, even for a developer who intends to sell or lease rather than use themselves. If they're clever, the benefits to be acquired increases the market value of the constructed asset. Why set an allowable cost before estimating what it will cost to get what you want? Why not reverse it and do expected before allowable? My answer is gap analysis involves comparing an expected cost to the allowable. You only change the allowable cost when convinced that it is infeasible. So it's natural to start with the anchor. Right? Okay. My screen seems to be stuck. Oh, there we go. Okay, a few comments about organizing for steering design to targets. So we've talked so far about setting targets, but as I say, you can have a wonderful target, but if you don't manage it, right, manage the actions of the project towards those objectives, then you're only going to succeed by chance, right? So this is the optimum organization for steering design to targets. So what we're seeing here are multiple cross-functional teams, but each of them centered around some aspect of in this case, building design, right? So MEP, mechanical, electrical, plumbing, structure, site improvements, landscape, material handling, vertical transport, interior finishes, building envelope. Okay, there may be others in special cases, right? I'm just trying to give an example. So each of these clusters, these TVD clusters, consists of, obviously, let's take structural. They would include the structural engineer, the structural fabricator, if it's steel, and the erector, right? And there would be a representative of the architect and of the construction management firm, if there is, presuming there is one, there usually will be, also sitting in on that team as permanent members. And of course, each of these teams have the right and to invite other people to attend their meetings or to ask to attend others' meetings if they're working on some aspect of design that is interdependent with what the other cluster team is responsible for. Yeah, make sense? I hope. Okay. So here's some basic steps in steering design to targets. So first of all, in order to determine if this project is feasible, you only need to know whether you can build it within the total target cost, right? But you can't steer design to that gross target because design happens, there are decisions made about at the level of components, of subsystems, of systems, right? And so you have to be able to express your target cost in those same terms. Otherwise, you don't have anything to steer to. It's like not having a map, right? So that's one of the first things to do. And then secondly, have cost modelers provide cost guidelines to designers upfront before design begins, right? And so the cost modelers are not designing, right? The designers are responsible for producing design alternatives, but those design alternatives must fit within the targets, right? And then thirdly, incorporate value engineering / value management tools and techniques into the design process. Now, I don't know if it's true in the Middle East, but certainly here in the United States, value engineering has gotten a bad reputation. And it's gotten that reputation deservedly, I think, because it tends to be used after the design has already been produced as a critique of that design. The most powerful and appropriate place for using value engineering is in the production of the design, right? The draft horse, the main method used in value engineering is function analysis. And that is a search for alternative ways of providing desired functionality at less cost. And that takes waste out of projects, right? So that obviously should be a driver of design, of initial design. And then fourthly, use computer models to automate costing to the extent feasible. So there's certainly a role for technology. Now that's kind of what we might call the technical side that I just went through. But there's also, projects are social technical systems, right? And if those aren't coherent one with another, they're not likely to work. So here's, this is again an example from something produced for Sutter. They call it their 5 big ideas. And I'll just walk through them quickly. So collaborate, really collaborate. The idea there is don't confuse collaboration with being nice, right? Obviously we want to be courteous, but if there's no heated arguments, right? If there's the noise level in a project, in the design floor of a project gets too quiet, there's something wrong. People aren't pulling their oar. They're not speaking up when they have concerns, questions, alternatives to express, right? So collaborate, really collaborate means work hard together and be be courteous, but be persistent about looking for the best solutions. Optimize the whole, not the part. Okay, we're looking at the delivery of value to the customer in terms of what they have expressed as desired net benefits, right? Tightly couple learning with action. So that means that we want to persistently and continuously learn through trying, right? This is the role of experimentation. Projects as networks of commitment, as coordination, as we will see this much more clearly when we talk about the last planner system in a moment. But projects really can be understood as networks of commitment. That is, the commitments made between different parties, one to another. And if there is a process for making commitments that should and can be kept, right? Called reliable promising. And I think I talk about that later on. And then increase relatedness. And this, I think everyone knows that. Well, let me go back to an old saying of Will Lichtig, who was the lawyer at the time for Sutter Health, outside counsel, who developed an integrated form of agreement, one of the basis for target value for integrated project delivery. And he said that it's all too often the case that we come together on projects as strangers and we leave as enemies, right? And that's no way to live. So increased relatedness means to get beyond the role I play, the role you play, to the persons underneath. And as another of my good friends, Philip Son, architect, says, you must break bread together. Here's a very simple example. It's a very small project. It's the first, to my knowledge, successful application of target costing, TBD, in the building, in the built environment design. But this one shows the allocation of costs to different functions, different building systems, if you will. So shell, interior, mechanical, electrical, and then some special ones, and site work up there. And in this case, what's different about these allocations of the total target cost is that they are provisional. The total target cost can only be changed by decision of the client, right? But we expect these to change. And an example of what that means is that it allows moving money across boundaries, right? So you need to have the right types of contractual frameworks so that that can happen, right? And in this case, the site work was allocated $594,500, right? This was in 2002, so it's gonna be more today, of course, but still a small building. And they immediately got into trouble. They wound up almost doubling that cost through a failure to identify soil conditions in a new placement of the building that was decided after the initial cost allocation. But they had some contingency, and then they also had mechanical and electrical had underrun their target costs, and so that savings could be applied to site work where it was needed, right? And obviously you need very special conditions, but those are the kinds of conditions that help projects be successful.
Dr. Ballard, we have a couple of questions, if you don't mind me asking them now, from Ghaffar. He's saying that when we do he's referring back to a few slides ago when you were talking about benchmarks. He says, when we do benchmarks, we're essentially using historical data. And he's saying that sometimes when you need to compare one project and then the next project is not going to be, it's not going to have the same basis, for example, in terms of technology or techniques used. So would it still be a correct thing to do benchmarking, and in
No, I
particular
think
with
that's no, I think that's a very good question, because it highlights the problem with benchmarking is that buildings tend to be complex in their functionality and to differ one from another in a variety of different ways. And so it's a very a rough process of making adjustments to compensate for those differences, right? Now, there's also part of our conceptual estimating research. There's underway in the United States a sharing of data in a program that allows you to do a much better job of benchmarking, if you will, because it enables the specification of cost to functions, right? And so there may be no such thing as a pure building type. Right? Buildings tend to have all kinds of different things going on in them. But if you're able to specify the functions that you want and to identify the cost of providing those functions in other buildings, right, then you have a more systematic basis for benchmarking.
Another question from Henry. He's trying to figure if there is a relation between the risk profile of a specific project and whether it has a bearing on the cost. So he's asking, is there any relationship between the cost of a project in terms of expected and allowable and the risk profile of the particular project in question?
Yeah, it depends, of course, but it's not unusual for if you identify a substantial number of, typically your contingency rises with the perceived risks and their expected impact and probability of occurrence, right? So, so certainly there should be some correlation. Is that enough for now? And that's a whole
Sure.
by itself.
Sure, by all means, yes. We will ask some more questions later.
Okay, so where we are is, here's some advice again. This might think of this as key points. To design for value delivery, understand how the facility will be used at occupancy and after before designing. Understand owner-client conditions of satisfaction for delivery of the facility, economic, environmental, and social impact. So it's really a sustainability perspective. Link what's wanted and owner conditions of satisfaction and keep them linked when either changes. Don't let scope and cost drift apart. And that's what tends to happen when you try to use design to set cost. Set stretch goals in scope, cost, or time to spur innovation, but carefully. Align commercial interest with delivery of value to the owner. That's so you don't want to incentivize negative behaviors. Design to target values and conditions of satisfaction. Do not design, then cost. One more example. This is going back to that St. Olaf College field house. We looked at the spreadsheet that was allocation of target costs to building systems. Well, that project was completed 2 years after a similar project, same functions, right, in a similar company, a college, a small liberal arts college in the same city, okay? And so we had an unusual ability to compare different approaches. So St. Olaf's used target value delivery, Carleton used design bid build, right? So the projects were completed in significantly different amount of time, 14 months for St. Olaf's, 24 months for Carleton. Even though St. Olaf's was a larger building, 114,000 gross square feet to 85,000. Total cost was less, and the cost per square foot was, of course, less. So about 2/3, I'm sorry, 2/3 of the cost of the Carleton College. And I don't know this for a fact, but I know I was told by the manager of facilities for St. Olaf's that a team of visitors from Carleton said that St. Olaf's field house was more beautiful and better fit for purpose than Carleton's, even though it cost less and was larger. Okay. So I'm moving into benefits here, and I'm only going to show a little bit. There's a lot more data out there in the literature. I noted earlier that in 2005, Sutter Health did that Fairfield Medical Office building that we looked at, right? In 2012, by invitation, I invited them to come to a meeting of the Project Production Systems Laboratory in Berkeley, and they sent their chief architect, chief planner, Dan Conwell. And so these words are Dan's words, the client's words, not mine. So they said they had launched, since they launched Lean in 2004, Sutter Health had completed 22 Lean projects greater than $10 million, some much larger, but at this point, no acute care hospitals. They're coming right after. Lean mainly referred to use of target value delivery and last planner. None were over budget or time. All were fit for purpose. And this is the words of the chief architect. They averaged 3.4% under budget and 15% under market. Okay. Now, later in 2012, this was, I think, in August, in October, November, they completed their first acute care hospital using target value delivery, last planner, and other Lean tools. This was quite a bit larger, $309 million, 130 beds and so forth. Yeah, completed in the third quarter. So here's some of the performance data. They completed under budget and 6 months early, no compromise to space program or sustainability goals. Construction rework, depending on the trade, was less from 15 to 80% than trade baselines. Productivity was 5 to 20% better than trade baselines. Mechanical and plumbing were installed exactly to the model 99% of the time. And I don't know, to be honest, what was the measurement of discrepancy, right? But we have a visual that I'll show you in just a minute. I think I have it. And there were fewer requests for information, change orders, and failed inspections than on Sutter legacy projects. So this is the comparison of model to photograph. Right? Okay. Key points. Steering to targets in design requires a budget that allocates the total project target cost to systems, subsystems, and components. Steering to targets in construction, we didn't talk about it, but requires a budget that allocates costs to work packages. Steering is done through feedback. Designers still design, but within constraints. The TVD fundamental rule is that only the buyer can change targets. TVD has consistently been used to deliver projects to targets or better. Okay, ready for some, have 10 minutes for questions. I think we're within shooting distance of being on time. Okay, so I wait for questions.
Okay, Dr. Ballard, can you hear me?
Yes, I hear you.
Okay, we have a few more questions that have been posed. One of them is, I think it's more of a statement imploring you to talk to the people at PMI and ask them to get Lean embedded in the heart of the iron triangle, if you will.
Oh, I know. It's yeah. That's if I live long enough, I'll work on that one.
Okay. Fair enough. Another one Ghaffar is asking is IPD. I think you actually did state that they use IPD type approaches with the TVD, with something that has used the TVD framework. Is that correct?
Yeah, it's not always the case that the examples that I showed, certainly they're using IPD. They're using the integrated form of agreement contract that Will Lichtig developed for Sutter Health. It's now available through to the general public through consensus docs.
Okay.
In the U.S. Okay. Yeah, in the U.S.
Okay. And so that is done hand in hand with it, like they've implemented TVD and then they used like a collaborative type agreement. Is that
Yeah,
correct?
some type of collaborative contract, right?
Okay.
Yeah, there's a range of those, obviously. And as I mentioned in my opening statements, I'd be happy to come back and give a talk just about that topic in the future. So
Sure, I think that would be great if you could do that. Another question relates to the topic of contingency. And the question from Shafi is, while preparing the expected project cost, do we have to consider the contingency factor? And if yes, what percentage would the contingency factor be?
I don't think you want to set contingency as a percentage of cost or the expected cost of the building, right? You want to set it based upon the needs you foresee for cost events that cannot be fully predicted, right?
Okay, fair enough. Another question from Ayman. He's saying that, like using BIM to estimate initial cost without a mature design might tend to be not very accurate. Do you have any suggestions for how you can make estimation using BIM more accurate in terms of predicting
Well,
costs?
it's quite accurate, right? According to Hatala's data, it's accurate. And I think that using their current version, which only went into use in the last few years, the accuracy is pretty amazing, right?
Okay, but maybe I think, sorry, go ahead.
Sorry, Farid, the question is conditional for immature design. So
yeah, like when you have an immature design.
I'm not sure. I'm not understanding that amendment. Maybe go back to the question again.
Maybe repeat the question. Yes.
Okay, let me read it verbatim. Ayman is saying, building a BIM to estimate the initial cost without a mature design will not be very accurate. What are the suggestions to make BIM approach more accurate? Perhaps he's talking to the fact that the model is not going to be detailed enough.
No, the model is absolutely detailed. The one that Hatala produces, you could build it. Okay, it's every fastener. It's got everything in it that you could expect of a buildable BIM, right? So the question is really, and this is part of the research we're doing, is that how do you allow for, you still want to have contingency, right? How do you embed contingency, and how do you quantify that contingency to allow for differences between that buildable design and another buildable design that also meets criteria, right? For functionality, for cost, for time. So,
okay.
But I think that the question, the assumption that those BIM models cannot be produced to that level, the level of detail that they can be built, is simply wrong. At least there's one instance on the planet where they are doing exactly that.
Okay, let's move on to the next one. The question Ghaffar is asking, has Sutter used lean or the IPD forms of contract in the project that you mentioned?
Which, the last one, the hospital project?
I think so, yes.
Yes,
Sutter Health.
Yeah, they use integrated project delivery as the delivery process, and they use lean for the management methods. Right?
Okay. A question from Prasanth is, have you had a situation where the project went over in time but was still under budget?
I don't personally know of one, but it could well be. I did write up, there's a paper that you can find from the, in the IGLC, International Group for Lean Construction, iglc.net has all of these papers, and you freely download. That's an anatomy of a failed project, right? It was IPD, it was TVD, it was LPS, it was everything, right? And yet it failed. And so that's an interesting one to look at. But interestingly, it failed, but it went 6% over the target cost, right?
Okay, sure.
Which I
Yeah.
think probably within the range of statistical predictability for most projects.
Yeah, sure. Okay, let's take another question. Sorry, go ahead.
Do we have time? I'm not sure. I don't want to rob us of the rest of it.
Okay, just a quick one. The process of applying TVD requires a specialized team set the targets and conditions to design, especially in value engineering. Is that correct?
No, I think that the tools of value engineering can be learned by anyone. You might want to learn from someone who's expert in them, but I think it's mainly common sense.
Okay.
I don't think it necessarily implies that you have to have additional experts on hand.
Okay, fair enough. Okay, we can ask the other questions later. If you would like to proceed so that we're not short on time, please go ahead.
Okay, so we're switching gears now to the last planner system of planning and control, right? So I have some words here about how it came to be, but I think I will leave that, and as necessary, I'll fill in the gaps. I want to start with an example of a construction weekly work plan. It was the first plan produced by Philip, who's the foreman of a pipe fitter crew on a wafer fabrication plant for Texas Instruments in Dallas, Texas, and it's in 1996. And I and Greg Howell, my colleague, were the consultants on the project, right, to this mechanical contractor, not to the whole project. So here we see that it's Philip's first last planner weekly work plan. And I think he did a pretty good job of meeting at least one of the criteria, and that is to express the tasks, the scheduled tasks, the committed tasks, in terms that are in the language of the people that are going to do the work. And so we may not know what gas/F.O.hangers/O/H and so on, reading in the upper left corner, what that means, but Silvano, Modesto, and Terry will know that they're to install gas and fuel oil hangers overhead in building K, and that there's 48 hangers, right? And everyone, for every day, they're working a 6-day week, for every day there is a specification that's intelligible to those who need to know about, that tells them what's to be done, how much, where, and that's enough information that they can determine, they can collect drawings, they can identify and requisition materials, construction equipment, scaffolding to be built, and so forth, right? So it's pretty good. So at the end of the week, there's this PPC column. If you look at the headings, estimated actual Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, PPC, okay? And PPC stands for percent plan complete. In other words, did Silvano, Modesto, and Terry do this task or not? And doing it doesn't mean doing half of it. It doesn't mean doing 90% of it. It means, did they do it? Right? So what we're looking at here is really different from the way we think about progressing a project in terms, say, of earned value. Right? What we're looking at is the reliability of the release of work between one trade or specialist and the next. And that applies equally in design as it does in construction. Right? So in this case, no, they didn't do it, right? And if we look at the whole list, we've got 4 no's and 5 yeses, right? So 5 divided by 9 is about 55%. Yeah. And he was trying, okay? So these are the kinds of things that go on projects, right? So why did the first one, the first gas fuel oil hangers overhead in building K, why didn't Silvano, Modesto, and Terry do that? Well, there was a change in the design that changed the length of the prefabricated hangers. These aren't just rod hangers, right? So, but Silvano, Modesto, and Terry didn't know that until they had already built a scaffold. They had hauled air compressor hose up to drive their equipment, and were prepared to start drilling holes in the ceiling in order to install the anchors for suspending the hangers to carry the pipe, right? And one of the design engineers happened to walk by and say, "Hey, don't you guys know we changed that?" And they shared, they said unpleasant things about his mother, right? Because they were, of course, if they had known, they wouldn't have been up there. So I went to look, I talked to the head of design, and they were co-located. They had a team co-located on site, as they tend to do in major industrial projects. And I said, "Well, when did you make this change?" 2 weeks ago. I said, "Well, we obviously have a problem in that you're not, we don't have a timely adjustment of the design information that, so in time that construction can decide what work to do next, right?" And we fixed it. So in the next one, obviously that's the risers. Risers are the pipes, the gas and fuel oil piping that go through those hangers. And there's a reference here to another feature of the last planner system. It says this was, the cause was the same as above. These guys worked on backlog and boiler blowdown. So if you look at the bottom left corner under workable backlog, we have boiler blowdown, gas vents, and rupture discs. So what they did was they, and this was part of the last planner system, is to identify for each team's weekly work plan, the kind of a plan A and a plan B, above the line and below the line. Above the line is things that you believe you can and should do. And below the line are things that you can do in case you need it. So in this case, they needed it because otherwise they would have lost that capacity, right? So now the next one, the next no, in the reasons for variance, it says material from shop received late Thursday, groove coupling shipped late, okay? Now, if we look at the schedule, they had been, Charlie, Rick, and Ben were supposed to have started the chiller risers on Thursday morning. So they didn't have any materials, didn't have the materials until late Thursday. So they couldn't do that work on Thursday. And they couldn't make it up because some key elements, groove couplings, were shipped late, meaning in the next plan period, the next week, okay? So what we did, this, excuse me, hang on one second, I'm gonna get a glass of water. I should have done that already. I think so. I'm not on the other side. Apologies for that. I'm back. Okay, so what did we do with this one? So as it happened, this mechanical contractor was supplying most of their own materials, certainly all the fabricated materials, through a fab shop located elsewhere in Dallas, Texas. And I said, let's go to the shop and let's sort it out. Let's figure out what happened. Why were they late, and why was the groove couplings not sent at all? At least not in the week. And what we discovered was the kinds of things you might expect. There had been some inappropriate responses, cost-cutting efforts that increased the intervals between maintenance, preventive maintenance on their transport, their trucks and trailers. It started having breakdowns, right? There was obviously no systematic way for the shop to know exactly what was going to be needed on their projects. And this was just one of, I think, 61 projects in the Dallas area, or others probably smaller. So we went to work and we fixed that, right? And we tracked the frequency with which materials were a cause of failure to complete a commitment on a weekly work plan, and it disappeared, right? So, and then the last one was an eye injury, a flash burn for a welder. Probably didn't have his hood down and he hits his rod on some piece of steel, right? So I just want to give you an example of the kind of flavor for what we're talking about here. First of all, we're looking at improving the reliability of work release, okay? And we're doing it at the level of production. We're not counting, at this point, we're not measuring progress. We're not directly measuring productivity. But I think it's obvious, but I will say that appropriately structured and used, improvements in PPC improve both schedule and cost in the form of productivity. So just so you'll know, for the designers in the room, it's not just a construction tool. This was first used on this project, which is a 7,000 seat fully enclosed amphitheater in Dallas, just by accident. It wasn't built. It was a developer speculative project, and economic tides turned against it, right? So, but nonetheless, it was taken quite a long way into design. And what we see here are, let me just read the first line. So it was divided into different parts of the design function. So this was site civil, there was architectural, there was interiors, there was structural, and so forth, mechanical, electrical. And so this is just part of we did a bi-weekly, a 2-week plan in this case, because we were located, most people were not co-located. They were in fact all over the country. It was an all-star team of designers, right? But I sat in in the architect's office, which happened to be in Berkeley, right where I was working. And so I was able to participate directly in those. And then we connected by phone and I think for the most part, with other people from around the country. So in this meeting on 7/1/98, the first of, no, sorry. Yeah, I think it's the 1st of January, 1998. HA, which I happen to know is the civil engineer, was to provide Texas accessibility standards requirements to the architect ELS, right? They said that they were going to do it on 7/07, by the 7th, and they did it, right? The second one, the architect, was to identify a preliminary and final Texas accessibility standards review process. They also committed to do it on the 14th and did it on the 14th, right? But then it goes a little bit south from here. So here we have resolve building storm, sanitary site collection points and pipe inverts, still lacking inverts, coordinate profiles with water lines surrounding the building to be deeded to city. So this is a complicated one. A lot of different people are involved, right? It was first committed to be delivered to be done on the 10th of July. It was not completed until then, recommitted for the 31st, and finally completed on the 2nd of August, okay? So that would be a no for PPC, right? And it goes on, okay? So we measured, so this is the PPC by, on 2-week intervals through from the 1st of July through near the 1st of November, okay? And you can see that it's, well, I think it was 68% was the average, if I'm not mistaken. Yeah, it averaged 68% over that 4-month period, okay? So that's not sparkling, right? Okay, now here is the last planner system. So we started way down in weekly work planning, right? And we explored a little bit learning from our experience, right? So what do we do what causes a commitment to not be completed? And what can we do about it? What countermeasures can we put in place in order to prevent that problem from happening again, right? But it starts obviously much earlier, and in the 2020 current process benchmark for the last planner system, it's been extended beyond where it was before to encompass project execution planning and master scheduling, okay? The first such extension, initially the project, the last planner system was really making tasks ready to be for commitment on weekly work plans, making those commitments, and then learning from our experience when they fail, right? In the early 1990s, no, early 2000s, the last planner was extended to phase scheduling, right? So what we advocated was at that time was that the master schedules be kept at milestone level, right? With the only exception being long lead items and options that need to be initiated in an earlier period in order to be preserve possible beneficial action in later periods. So, but other than that, we said, well, let's plan, let's get our master schedule that's given to the last planner system, if you will, and then let's develop the plan for moving between milestones, the phases of the project, using phase scheduling, a pull planning approach, right? And I'll talk a bit about that later. So let's see what we got. So why did we extend the last planner system to manage the entire project? I think perhaps the most fundamental reason is that it just doesn't, on reflection, after 20 years, it didn't seem to me to make sense to have two different systems, right? One that's focused on project performance and the other on planning and control system performance. They're so intertwined, right? And in addition to that, we had three concerns with current practice: failure to involve the right people in planning, being overly deterministic in the face of uncertainty, which in the construction industry is rife, over-reliance on the ability to predict probability of occurrence of risk events, okay? So in response to that, the countermeasures were use pull planning to produce the initial production. It's not the only thing you do in scheduling, but to produce project master schedules. And in this new benchmark document, there will be a description of a process for doing that. Incorporate alternative pathways in project schedules, okay? And that's an application of stochastic planning under conditions of uncertainty. And it's the general term for that is hedging, right? And hedging is like buying an insurance policy. You know it's going to cost you, and so you have to be careful to calculate whether the benefits of hedging, that hedge, exceeds its costs. And that's in a research project that I've noted here, available at p2sl.berkeley.edu, or will be when I finish it.
Dr. Ballard, can we ask a couple of questions at this
please.
point?
Yeah, give me a chance to catch my breath.
Okay. Okay, we have a few related questions. I'll ask a quick one from Mr. K. Matut. What is the role of planning and forecasting in the last planner system?
The role of planning and forecasting?
Yeah, I mean, I think, you know, like, because in this part of the world, we still do a lot of projects the traditional way. So you have like a planning department that does things, you know, like using the critical path method.
Yeah, well, there's still going to be specialists like planners, schedulers, uh, and estimators and so on. We're not trying to get rid of people, but I'm trying to put it all under one hat, right? So we're looking at one and the same time at planning and forecasting the project and controlling it, right? And continuously trying to improve the functioning of the planning and control system. As an example, if we can improve reliability of work release, right, of workflow from, you know, through different specialists, then we can better impact project performance.
Okay, another question. I'm going to read it verbatim so I don't judge the question or what is intended behind it. Dr. Ballard, so can you confirm, in essence, partial progress isn't the ideal way to record progress for PPC?
Yeah, PPC doesn't measure progress. I think it's a variable, a factor that influences progress, but it's not directly a measure of progress, if I'm understanding the question.
Yeah, I think that would answer it. That would make sense.
Mm-hmm.
One.
What I argued long ago when this first came, I first started writing about this, was that we tend to have, you know, we look at like dials in a cockpit when we're trying to manage a project. And so what do we have on our dials, right? And obviously we have, where are we in terms of conformance to budget? Where are we in terms of conformance to time, right? And what I argued was that we were missing one that measured something that impacts both of those, and that's reliable release of work, and that's PPC measurement.
And of course, by extension, flow, right?
Exactly. No, exactly. That's the whole. It's all about flow, right?
Yeah. Okay. Another quick question. When comparing PPC with the earned value method, the project team will find it hard to understand the impact of PPC being low. However, percentages from the earned value method is easy to be understood. What do you think?
Well, I think that they're still trying to answer the question, where does the project stand in relationship to its schedule targets, right? And PPC doesn't try to answer that question. It tries to answer the question, are we doing what we say we're going to do?
Mm-hmm.
Okay.
Okay, fair enough.
But I can just point out that one of the problems, and this has been pointed out in writing, in publications many years ago, one of the problems with the earned value method is that it doesn't value sequence. And so a common occurrence is that late in projects, you turn out to be over progressed because the work that you were doing, because of doing work out of sequence, you increase the labor intensity, the amount of labor time needed in order to complete work. More time is needed than was in your original plan, right? So I think if you want to use earned value, you need to have some way of weeding out and devaluing out of sequence work. Obviously,
okay.
you'd like to prevent it, first of all, right? But if it does happen, then you want to make appropriate adjustments because otherwise your forecasts are wrong.
Okay. May I recommend that we press on and then maybe ask some more questions?
Sure. I appreciate the interruptions. Actually, it's good because it gives me a sense about what people are taking in. So.
Okay, we've got quite a few questions. We'll get to those in a bit. Perhaps.
Okay. Okay, so here, so on this question of kind of what we've tended to do with regard to planning under uncertainty, speaking about it as variation, some variation is statistically describable, right? So if you want to know welding error rates, right, or deep drawing design rates, I've measured rates for the errors in piping isometrics when I was with Bechtel, right? So, and it was about 5%. So it's not negligible, but you can buffer it because it's statistically describable. There's a frequency distribution that you can attach to it, right? And use that for calculation. But there's other types of variation that aren't statistically describable. They're indeterminate in probability of occurrence. And so, in my experience, and maybe this isn't characteristic of Middle Eastern experience, I don't know, but that the common approach is to assign a percentage of probability of occurrence to a risk event and an estimate of impact should that risk event occur. And then you multiply those two and you get something, a number that allows, it's really a kind of priority measurement for mitigation, right? Now, I suggest that if you do that beyond statistically describable events, then that product doesn't mean anything, right? Because you are not able to actually estimate probability of occurrence. So there's a paper on this, and the paper is referenced right there. And again, I can refer you to iglc.net for that paper if you're interested. So, so buffering can't really function in the case of indefinite probability high impact events. And there you really have to focus on increasing flexibility in plans and increasing flexibility in teams, right? And there is some data to show that the use of the last planner system increases teams' flexibility to be responsive to changes, even changes in project objectives, and not only in pathways to achieving those objectives. Okay? So as regards flexibility in plans, what we tried to do, here we go. So there are two basic techniques that can be used. Postponement, for example, planning in greater detail as time for execution draws near, making decisions at the last responsible moment, not the last possible moment, but the last responsible one, allowing for variation if there is. And then hedging, developing or buying an insurance to offset potential losses or gains. And we have one example from set-based design, develop a fallback alternative design in case it's needed to meet the last responsible moment. And that's also a feature of the last planner system, as I just illustrated in the case of the wafer fabrication plant. And then also embed alternatives in project master and phase schedules. The assumption that that you can plan a project, every project, so that it provides only one pathway to objectives seems to me to be foolhardy, given the level of uncertainty that is characteristic of construction projects, and especially more complex and larger ones, right? And so we've provided a case instance of doing the calculation of embedding alternatives, options, right, in master schedules, and then assessing them to see if their potential benefit exceeds their cost. Because like insurance policies, options always have a cost. And so you must be able to calculate their benefit versus cost ratio in order to make a good decision about whether or not to do them. And that's again in this, there's a research report that'll be published by the Lean Construction Journal that describes that case, that provides that case process for calculation. So flexibility in teams. So I came through the good offices of the suggestion of Greg Howell, with whom I co-founded the Lean Construction Institute back in 1997. he put me onto this notion of psychological safety. And if you want to get a quick feel for it, you can find on YouTube Amy Edmondson, a Harvard professor in the business school, has about an 11-minute talk on psychological safety. And I think if you either put in Amy Edmondson or psychological safety, that talk will come up. And basically, we're talking about the importance of people working together, feeling safe to speak truth to power, to make suggestions, to request feedback, to expect help when mistakes are made, not harm, and to perform experiments, right? And so we've done some measurement. We're doing, I have a PhD student now doing her dissertation, applying psychological safety attempts to improve it and to demonstrate how it can improve processes, specifically quality management processes. So in this I mentioned briefly this cultivating the habits and skills of creating your own future, applying the last planner principle that work is planned by those who do the work. So that's a way of increasing flexibility in teams. And there's also published reports, some in the IGLC on that impact. Okay, so here are the countermeasures for poor quality of work plans and schedules in the LPS. Master schedules are kept at milestone level of detail. Phase schedules are developed by those with direct responsibility for doing the work being scheduled, filling in the gaps between milestones and the master schedule phase by phase. And scheduling is done at more detailed levels near in time to scheduled execution. And this is the rolling wave approach, at least one word for it. So moving from project to phase to process to operation to step. So this is a nomenclature for task breakdown. Right? Now, why do we want master schedules at milestone level? Right? Now, I want to note that I'm talking here about the master control schedule, right? Not the project execution plan. So in a project execution plan, you will should consider many different situations, different contingencies, different risks, different opportunities, right? But all of that detail should be reserved in terms of control, right? Because it's too messy and too unpredictable, too indeterminate, right? And that follows a theorem that I think everyone in the world knows except construction. Forecast error increases with the length of the forecast period and the level of detail. And so if you have a 10,000 line item CPM, right, your likelihood of being right on track 3 months into the start is almost nil. Right? So let's plan in greater detail as we get closer to doing the work. And one of the ways of doing that is pull planning. This is the stickies on the wall. There are some softwares now that are kind of computerize the wall, if you will, but it's still useful for people to physically be together, although it's becoming limited in the COVID times, right? In order to practice reliable promising. And one of the primary reasons for pull planning, that is starting, say we're targeting a milestone, right? The completion of a milestone, and we want to move from that completion back in time, right, to the start of that phase. Now, why go backwards? And the fundamental reason is because we want to initiate the process of reliable promising, right? So if I need something from you, I make that request, right? And that would be represented by a sticky on the wall, right? In my color code. And that would say on that sticky whom I'm making the request of, what the request is, right? And so deliver the soils report by 7, July 15th, 2020, right? And so let me, that's enough for now. I'm going to go into the reliable promising process shortly. So it goes like this. You start with defining what you're going to come out with, right? Where you're starting from. That is what you're working to, planning to. Define deliverables and scope. What will count as successful completion? I remember one such event. We were trying to plan a building to slab on grade. And we spent 45 minutes getting agreement about what that would mean. You would think that there would be a standard definition, but there isn't. There's this little detail and that little detail. Will this be done or will this not be done? And so spending time at the beginning to make sure everyone understands what's the goal, what's the target, pays off. Develop a logic network using a backward pass, right? Apply unpadded durations to activities. So you're trying to the best, you may have data, but more often, at least certainly when you start, you probably are using intuition based on your experience, but at least don't deliberately pad durations of activities, because otherwise you're going to have too much float, right? More than you need to absorb uncertainty or variation. Replan as needed to generate a schedule buffer float to absorb expected variation in durations, and allocate the schedule buffer to critical and variable activities. Okay? So this is, I think, pretty straightforward scheduling. So what tends to happen on the first attempt, if we have a target milestone on the right, date phase of work must end, we've worked backwards in, some of the lines aren't so clear, backwards to the start, and the date phase of work can start, right, is later than our plan. That obviously won't work. And it won't work for two reasons. This doesn't have any schedule contingency, right? And it still doesn't fit. And so that's when the conversations really get important, right? So you go back and you ask, look, can anyone, all of you are customers of someone, right? And suppliers to others, right? Is there anything that anyone can give you that's different from what they're giving you now, or perhaps at a different time, different level of quality, different completion, whatever it is, right? Let's ask for it, make a request, and then we can work out. And also, when you remember that picture of people around the wall, and some walls are covered, right? Big rooms would be covered with stickies going around, you know, all the way around the room. So there's remember we said projects were networks of commitments. This is at the nitty gritty level, creating that network through individual conversations of different people, interdependent people working together on the wall, right, to get it right. So I can tell you an example from a project where we were pulling some phase of design, I've forgotten what, and we got this in this situation, so we had to take some time out somehow, and so we made that appeal, and Rebecca, the electrical engineer, said, "Yeah, if Bill would give me the electrical equipment in a spreadsheet with all of the amperage and the voltage and the footprint and all those requirements, that would be really good, because it takes, right now I need 2 weeks to do my work once I get that information from him, but half of that time is spent kind of cleaning up the mess, right?" And so I asked, "Well, Rebecca, have you ever asked Bill that?" No. And with the implication in her voice or tone of voice that she shouldn't have to ask. Well, is it better not to ask, or is it better to suffer for the rest of your life, right? So Bill's right down there on the wall. Let's go talk to him. And she says what she makes her request of Bill, and Bill says, sure. I didn't know you needed that. Now, you might think, well, it's really weird that they wouldn't know, but if you don't talk, you don't find out, right? Things just keep going on and on and on like they've always done. Right? So, so that can allow you, if all those conversations, right, all those individual conversations aggregated into a logic network, right, can allow you to then identify critical in the CPM sense of critical and perhaps variable, risky tasks that need buffer, right? And so the idea then, you would calculate it by calculating it from the date phase of work can start and the time when the first act in that phase of work is scheduled to start by your plan, the one you just created. But you put it in the back, right? And where you can draw it down a la Goldratt, right, as you need it. Now, one of the challenges is if you're working in a situation where your different players have independent financial incentives, payments, they get paid differently for different things, right? Then every time you draw down on your end of buffer, end of phase buffer, you change the start dates, right? Just think what that would mean for a series of specialty contractors. Right? So the attempt in those circumstances is to try to distribute the float so as to protect the end date, right, without changing the start times as much as possible. So reliable promising, I think I've talked enough about it. So just to rehearse real quickly. So it starts with a request, right? The first response is not yes or no, unless you're absolutely certain you understand what's being asked, right? But rather clarification. And you might say back this, are you saying X, Y, Z? Am I right in understanding you to be asking me to do X, Y, Z, right? There are various ways we can do clarification. We do it all the time, right? But let's make it part of our business practice. And then the third step is negotiation. Unless I know I can and should do what you're asking me to do, right? And I'm confident I know that we have the same, we're like-minded on what's being requested, right? But otherwise, you answer yes if, right? Yes if, and then you name a constraint that has to be removed in order for you to be able to do it. Yes if I get the groove couplings in time, right? Okay. Or you might make a counteroffer. You might say, no, I can't give you everything you're asking for, but if I give you this part, I can do it at the time you're requesting it. Would that help? Would that be useful to you, right? So these are the kind of, these are all talking to each other, conversations, right? That really make projects run or not run. So you want everyone to be adept at reliable promising, because it happens everywhere, not just in the production of schedules or weekly work plans, but in determining quality requirements for an installation. Okay. Like I'm running out of steam here. I'm overlooking something I should be saying. Okay, so now let's look ahead planning. So we talked about project execution planning, master scheduling, phase scheduling, now look ahead planning. So look ahead planning, as it says, has three different parts. Identify and remove constraints on scheduled tasks, break down tasks from processes into operations, and design those operations unless you already have a standard design that you're confident is appropriate for this time and place.
Dr. Ballard, can I just ask you a quick question about phase scheduling?
Sure.
In my work experience, we use something similar to Last Planner. I mean, that's a topic for another discussion. But
Okay.
phase scheduling typically is how many months look ahead, or does it go by like whatever length of time that particular phase would take?
No, it goes by the length of your look ahead window, right? Because there's, say you want to start identifying and removing constraints 6 weeks ahead of time. That may not be enough if you have extended supply chains, right? You're in outer Slobovia or something. So that's just a normal time, but you need to calculate it to the best of your ability. How long will it take you to fix a problem that should have been fixed before but isn't by the time you're in weeks ahead of scheduled start, right? Does that make sense?
Yeah. I think so. That's a determination you make early on in the project.
As part of your work, it's a fundamental structure for your project plan. Yeah. Right.
Okay.
Yeah, but I would say if you do have a 6-week look ahead window, you want to start the phase scheduling process at least 6 weeks ahead of scheduled start of that phase. But just put an in there to make it more general. Okay.
Okay. Thanks.
Sure. Okay, so let's take this one apart. I'm going to talk about constraints first, then task breakdown, and then operations design. So you don't, generally materials and design information are the primary constraints, the absence of which make it impossible or implausible to actually carry out a scheduled task, right? So you want to identify those earlier. Now, if this is the fail-safe part of the planning system, right? But we have people responsible for materials, for coordinating with design, or design coordinating with the earlier design, right? And if they're doing their jobs, they will know already, and they can give us a heads up. Well, which of them are we're supposed to get these? Let's say we're supposed to get submittals, right? And we don't have them. When are we going to get them, right? And so this reveals if you have a significant amount of problems here in the look ahead process, where you haven't removed constraints that should have been removed already, then you need to go back and look at your material management system, whatever system it is that is responsible for removing those constraints, right? But we will have problems, and so we need this function, this look ahead planning function, so that we can fix as many of these as we can, especially those that are critical tasks, right? Not doing them when scheduled will push out the project unless you can replan around it somehow. Okay, so this is just using a 6-week look ahead period just as an example. So we analyze materials and information constraints, and I should say get commitments to removing those constraints, right? And that might start with a commitment to give us an update, right? Just a status report. They were supposed to have been here last week. They're not here. What's the story, right? So this obviously is going to involve not just direct chain of command people, but also people working on managing different flows, right? So so you should be able after the first 3 weeks between 4 and 3 to select operations to be released for commitment. So because the downstream constraints are typically those that can be dealt with, repaired if needed, or made to happen within the remaining time, right? And if you're wrong about that, extend your window. Right? So then in week 3 or perhaps 2, you design operations with the people that are going to perform them, right? The craft workers, if they are, the designers, if they are, whatever, whichever they are. We want them to be involved in designing those operations because the performance of that operation, the execution of that operation will be its test, the test of that design, right? So you want the people who to feel responsible for that design. It's their own, right? Obviously, it'll be influenced by opinions and information provided by lots of other people, but they should certainly be there. And then we would go into analyze resource and permitting constraints. Some permits may well be longer lead, but most of them will be like a fire permit in a refinery, right? Open fire permit. You should be able to get it within a day, right? But of course, it depends on what your situation is. And then on week 1, ahead of start, you form the weekly work plan, you make the commitments, and you're making commitments by selecting from scheduled tasks that have been vetted. They've been released for commitment, right? So you don't want just people to just go out and make up what they're going to be doing, right? You're actually shaping what they're going to be doing. And then execute the weekly work plan, status it, and of course, learn from it, okay? So we'll go through those. I don't think this is, I think it's obvious what constraints analysis is. This is a very simple example showing that, showing some of the typical things for a construction constraints, contract or change orders, design, complete design, release for construction, submittals, RFIs, requests for information, materials, labor, equipment, construction equipment, prerequisite work, space, and is this sound, right? Now, that's not sound entirely because we're expecting this to be delivered, the materials to be delivered on Monday morning, and we're planning for Monday morning, right? So we may well decide, yes, let's go with that. We've checked with the delivery service, right? They promised to be here. They have a good track record. Okay, that's a go. This one is sound. There's only X's there. Oh, and by the way, the assumption, the operating assumption is that there is a constraint unless you know there isn't, right? So and that's the opposite of how we normally operate, I think, or more commonly operate, is we only respond to problems as we perceive them. Well, this is a way of making sure that we're not seeing all the problems, right? Making sure that we do see the problems, hopefully in time to fix them. Right? Okay, so that's an example there. So here now, so this is taking an example of a construction operation. I could give a design operation. I think maybe I do. But there's no established nomenclature for a set of names for different levels of task breakdown. So I've just proposed one. So did this several years ago. But so I propose that we can usefully break up tasks, scheduled tasks, right, into project, phase, process, operation, and elemental motions. Okay? Operation steps and elemental motions. Okay? So we take an example here. If we have a building project, let's call it 101 Calhoun. It will be have different phases, perhaps with some types of buffers in here, contingencies, scheduled time contingencies. So if we take one of those, say substructure, that phase, we can break it into processes: excavate, shore, place, drill, caissons. Okay, we can take one of those phases, place, drill, caissons, and processes, I'm sorry, and break it into pieces, right? And then those pieces are operations: fabricate the cage, drill the hole, place the cage in the hole. Let's take fabricate cage, that operation, and break it into steps. And this is from an actual project, the Terminal 5 project at Heathrow Airport in early 2000s, where we used a mechanical machine system for fabricating caissons. So step in, place straight bars in cage jig. Step in +1, weld helical coil to straight bar while rotating jig. Step in +2, fit and tack lifting bands. Right. And then
Dr. Ballard,
yes,
the triangles are buffers, and of course the normal assumption is to assume they are material buffers, but you said that they also could be time buffers. Is that correct?
yes, they could. I mean, we could have capacity buffers too. Those are the three basic things we can use as buffers. Right?
Sure.
Right. But I'm just saying that there's some release between fabricate cage and drill the hole, right? And so we may stack up cages inappropriately or appropriately, depending upon the rate at which they are able to be placed in holes. And on the Terminal 5 project, we wound up getting way ahead of the game, right? Because the drilling and installation wasn't going as fast as the fabrication. So, and that just causes space problems, equipment demands, and so forth. So the last piece is motion analysis, and the science of elemental motions was developed by Frank Gilbreth back in the early 1900s. And Thurbligs is the unit of analysis, motion analysis, and that's a mixture of a jumble of Gilbreth's name. We will be using those as we move into more robotics in fabrication shops, right? Because that's what you teach. You teach you grasp, rotate, drop, release, right? Okay. So how are construction operations designed? Through virtual prototyping, physical prototyping, and mock-ups are common, right, that we use those, and first run studies for repetitive operations. So first run meaning the first instance of the operation design is a test of that design.
So are you advocating, Dr. Ballard, are you advocating first run studies for all the phases and operations and everything, or just for select ones?
Well, I think you ultimately for everything, right? That's the lean principle of developing standard process, right? Standardization. And if you have a standard way of doing something, then you can improve it. If you don't have a standard way of doing it, you don't improve it. Right? So.
And are you talking about one particular project, or you do it on one job and then you can use that study or the results of the study for other projects?
No, you would want to record it, keep a library of method of operations designs, and with as much information as you can about context, right, where it would be appropriate or inappropriate in use. And so obviously, so I say that you want to design the operation unless you have a design that you're confident is appropriate for use in the circumstances of this project.
Okay.
Yeah. And by the way, I was brought into the University of California, Berkeley Civil Engineering Department to teach students how to design, how to do this. And
okay.
film operations, to analyze them, to find better ways of doing it, right? So, okay. So, feel like we're getting close to time, so I'm going to skip through. All of this information will be available to you, right? Let me get to,
sure.
Oh, this is just going to the benefits just quickly. So one of the early applications of the last planner system was on a project, a refinery expansion project, $1.2 billion in 1994 dollars, right? So it's big, for PDVSA, Petróleos de Venezuela, in the only stinking desert in Venezuela. And one of the things we did was this is to the point of the importance of developing operations design. So these are different, they call them subcontractors, but they actually had broader mandates than that. But ATA was doing pipe supports, 3 supports a day. They went to 22 after designing their process. Costa Norte went from installing a 54-inch diameter cooling water line in 4 hours and 19 minutes to 32 minutes. Denspy wiring, doing electrical wiring in junction boxes, 1 wire every 5 minutes to 1 wire every 3 minutes. Distral from 10 ISOs a week, piping isometric drawings installed to 15, okay, and so forth. So that helped in that project complete on time and budget, even though a year from schedule completion, it was way behind both budget and schedule. And that's also written up in the, I think you can find it in, you'll find it. So PARC project. That stands Proyecto Adecuación Refinería Cordón. So,
yeah, I think we can find it on the IGLC website, probably. One of them.
Yeah, my only concern is that it may not be, because the first 3 years were published by Balcoma, and I don't know, I think it might be in that first 3-year period. But at any rate, if you can't find it, let me know and I can send it to you. Okay, and this is an example about a BIM stress test to show that this doesn't, designing operations doesn't just apply to construction, but I will leave you to peruse that. Okay. So we talked a little bit about this, that kind of a rule for committing to plans, to tasks in a weekly work plan. Want them to include only tasks that are defined to convey what performers need to understand. They're sound, as they have no outstanding constraints that can't be removed before start of execution. They're sequenced with critical tasks first, so you're applying capacity that best advances the project, and size to the capacity of performers. Let's see. Okay, this is an example of the improvement in PPC for one of those companies in Venezuela. They went from about 65% to about 85%, okay? And this is from a refinery project in, a BP refinery project in Indiana, actually Whiting, Indiana, where we had numerous pipe fitter crews. So, and we had data from each of those crews by week for their PPC and their productivity expressed as a performance factor, okay? So, so that allowed us, we could calculate this line of best fit. That's the equation of that line. And so we can use that to forecast productivity from PPC, right? Okay. So if PPC was 50% on this project, they would have been 4% better than their productivity budget. And that tells us that productivity is based on previous experience, right? And their previous experience was that they were experiencing a PPC of about 50%.
Dr. Ballard, let me just start asking you some questions on PPC that I've been meaning to do afterwards. A couple of the people attending are asking, should you use PPC as part of the appraisal system or for punishment / reward type thing, maybe tie it to that, or is that
no,
not a good
I
idea?
wouldn't do that. No, I wouldn't do that. I think what you want to do is to persuade people that, I mean, I think most people take their promises seriously, right? We don't always ask them to use that side of themselves in the workplace, but I think we should, right? So if they fail to have a good PPC, that doesn't necessarily mean that they're to blame, right? They
Sure.
might have, right? I mean, you can't, you know, we overestimate the importance of motivation, right? You cannot weld with the fire in your eyes. You need welding rods and welding machines and lines, right? Right. So I would discourage using it as a way of, you might use it as a way of rewarding. If you can demonstrate an improvement in productivity over the course of the project, that would be worth rewarding, right? Maybe just with a pat on the back, but money also matters, right?
Indeed.
Okay. So, and this also gives an indication of the level of improvement possible through simply the last planner system's impact on productivity. But I want to caution you that the last planner system is more important than just its impact on productivity, right? It's fundamentally an engine for continuous improvement, right? So if we are able to, if we can learn by learning from our breakdowns where we break promises, we don't keep our commitments, to find those root causes and eradicate them, and they may go way back into policy levels, certainly back into the supply chain, right? Then we can do more with less and faster and safer. Right? So, okay, let's see. I think I have way too much material, don't I? So here's some differences between the traditional approach and last planner approach. Planners plan and doers do. Planning is done collaboratively. Thermostat model of control means control starts by the identification of a negative variance between should and did. And control is also, in last planner, proactive. For example, making ready in the look ahead process. Inconsistent learning from planned failures versus systematic learning. Scheduled tasks are pushed onto doers without regard to readiness. What are you going to do next week? Read the schedule. Okay. The question
Dr. Ballard, can I give your throat a break and ask you a couple of questions maybe
please,
related to this?
make it a long question.
Okay. A couple of the attendees have asked about the relation between last planner and the baseline schedule, if you will, or even whether LPS will take away from Primavera, from, you know, like planning. So I don't know if you could share some thoughts on that. Are they independent? Are they interlinked somehow?
I think they're interlinked in the sense that I don't think that CPM is fundamentally a calculation of the longest path through a logic network, right? Sure. And that's useful. I don't intend to obliterate that. What I would like to change is the practice of producing deterministic, highly detailed schedules that are more likely to be wrong than right. Mm-hmm. That's why I want last planner to control that function, right?
And let's also remember that traditional planning is about project management, whereas LPS is about production management, which is more detailed, right? It's more lower level.
It has been, but now I'm collapsing that distinction. Okay.
Can you elaborate on that, please?
Well, I think that the fundamental principles of the last planner system should be applied to project planning and control overall, okay, not just to production. And I think that we're not going to change this, the pernicious practices of project management unless we take it on directly.
Mm-hmm. For example, doing things like clean work structuring.
Exactly.
Structuring.
Right. Yep. Okay. Yeah. For example, yeah, using TAC planning, for example. I don't know if that's a term of art, but that's we're now recommending in this new version of the last planner system that's coming out. We're recommending that where appropriate, where space is a variable that's of moment, that all projects have location-based work structures.
even if they were not repetitive elements, Dr. Ballard?
Yes, no, that's exactly right. Because we're working now. That's actually research that my colleague Iris Tomaline, Professor Iris Tomaline, is leading to incorporate repetitive and non-repetitive work into TAC plans. And that she's made she's got publications on that. I think she's pretty much got it whipped. So.
Okay, and I think I've seen that on IGLC, so
Yes,
the audience could refer to that one.
Exactly. Yeah, because it's no, I mean, I went to a project where they were using a kind of more or less a slavish imitation of manufacturing's approach to TAC planning, where they only looked at repetitive operations, and less than half the project was on the TAC plan. So I'm not quite sure what's the point of finishing all the verticals right before you finish the whole project, because you can't do anything with them. So
yeah.
No.
Okay.
Okay. Okay.
Yeah.
Let me wrap up. I think we're well after time. So so some more last planner fundamentals. Okay. And this is all of this is abstracted from the process benchmark for the last planner system. And that you can get a lot of benefit out of the 2016 version, which is available both at the Lean Construction Journal, which is an electronic journal, so you can take things right away, and at p2sl.berkeley.edu. So, okay. Okay, so key points. Systems executed by people are social as well as technical, as opposed to the traditional view that people are what screw up otherwise perfect systems. People are what make systems work if you engage them properly. Reliable promising is the social glue in human systems, but you can't make a promise if you can't say no. And being able to say no requires accepted rules of behavior to which everyone in the system can appeal, even someone subordinate to someone else, as long as they both have, it's a matter of principle, committed to those rules. Last Planner is an example of a management system that integrates the technical and social.